Hi dear students, how are you? Today we will discuss the curriculum, the topics of this curriculum, right? So we will start from our first topic, that is number theory and computation. So first of all, you should know how to distinguish among the sets of numbers, right? So I will briefly discuss these topics without going into much depth because these are very simple and easy topics. So we will see what is natural number. What are natural numbers? You can see natural numbers start from 1 and goes up like 2, 3, 4, 5, 6, 7, 8, right? So natural number is represented by n, capital N, right? And what are whole numbers? Whole numbers start with 0 and then continues like 1, 2, 3, 4, and up to so on. So what's the difference between natural numbers and whole numbers? Natural numbers starts from 1 while whole numbers start from 0, right? Then you should know what are integers. Integers are 0, then all the positive and negative numbers like positive 1, negative 1, positive 2, negative 2, positive 3, negative 3, right? You may also represent it like this: 0, then positive and negative 1, positive and negative 2, and up to so on, right? So these are integers. Integers are represented by z. Then what are rational numbers? Rational numbers are the numbers which can be written in the form of p over q, right? Like any fraction. If we have a fraction like 2 over 3, it's a rational number, right? If we have 1 over 2, it's a rational number. If, for example, if we have just a number 15, it's also a rational number. Why? Because if there is nothing in the denominator, there is always 1. So 15 is also a rational number. The condition here is that q should not be equal to 0, right? For example, if you have a number 3 divided by 0, then it's not a rational number. The condition is that the denominator should not be equal to 0. So this is not a rational number. For example, 2 divided by 0, this is not a rational number, because whenever any number is being divided by 0, that will be considered as an undefined number. So if the denominator is 0, then it will not be a rational number, right? Then what are irrational numbers? Numbers that cannot be expressed as terminating or recurring decimals. For example, numbers such as pi and square root of 2. You should know the numbers like pi, e, and square root of 2. These are called irrational numbers. Why? When you convert it into a decimal, you can see, for example, pi, this is the value of pi at the right end. If you can see, it's non-terminating, right? This is a non-terminating decimal. That's why it's an irrational number. So you should remember pi. I think you should know about pi, that is 22 over 7, right? This value, if we divide the number, you will get a recurring decimal, a non-terminating decimal here. So it's an irrational number. Similarly, e is also a constant. You should know its value is 2.71 and something, but it's also non-terminating. It's also a non-terminating number, so it's also an irrational number. Similarly, square root of 2. If we calculate it, like if we take a calculator, right, and find the square root of 2, you will get a number which is non-terminating. Here in the calculator it's not showing, but it's actually a non-terminating number, right? So it's also an irrational number. Similarly, the numbers like square root of 3, square root of 5, and all that numbers, that are considered as irrational numbers. But for example, if you have there are few numbers which completing square numbers, right? For example, square root of 4, you know, it's a complete square. 4 is a complete square. So the square root of 4 is 2. So that's a whole number, right? So square root of 4 is not an irrational number. Similarly, square root of 9 is 3. So it's also uh, it's not an irrational number. Similarly, square root of 64 is 8. So it's not an irrational number, right? So this was the concept of irrational number. Then we will see what are real numbers. Here you should know two things. Rational numbers are represented by q, while irrational numbers are represented by q prime, right? Then what are real numbers? Real numbers, the union of rational and irrational numbers. So real numbers contains all the rational and irrational numbers, right? So real number is represented by r, and you may say it's the union of all rational and irrational numbers, right? Then what you can see here, And natural number is a subset of whole number. Whole number is a subset of integers. Integer is a subset of rational number, and rational number is a subset of real numbers. So what it shows, you can see all natural numbers are included in whole numbers. All whole numbers are included in integers. All integers are included in rational numbers. All rational numbers are included in the real numbers, right? So then what we can see, what are odd and even numbers? It's very simple, the numbers, odd numbers are those numbers that cannot be divided into two equal parts. So you may define odd numbers in many ways. Like if we look at the numbers 3, 5, 7, 9, they are not the multiples of 2, right? In other words, when you divide them by 2, you will get the remainder as 1, and you will not get the remainder as 0. So these are called odd numbers. And what are even numbers? You can see they are multiples of 2, right? Even numbers are those numbers that can be divided into two equal parts. So if you divide any of the even number by 2, you will get the remainder 0. For example, if we can say 60, 60 is an even number, right? Similarly, if we look at the number 53, it's an odd number. So, for example, if you have a larger number like 2, 4, 4, 5, 6, right? And if you have to decide either it's an even number or odd number, you will look at the first digit. You can see it's 6. If 6 is an even number, the whole number will be an even number. So here 6 is an even number, so this whole number, and as a whole, it's an even number. And if you have a number like 4, 3, 5, 7, and if you have to decide either it's an even number or odd number, you will look at the first digit. You can see it's 7, and 7 is an odd number. So this number as a whole is an odd number, right? So that was the concept of even and odd numbers. Then we will see what are prime numbers, right? Usually they are represented by p, right? And a prime number is one which has exactly two factors, which means it can be divided by only one and itself, but one is not a prime number. So in the set of prime number, like if I represent the set of prime numbers, it always starts from 2, right? 2, 3, 5, 7, and up to so on. Like 9 is not a prime number because it has three factors. The reason behind that, 1 is not considered as a prime number because 1 has only one factor, that is it's 1 itself. But all prime numbers, if we look at 2, it has two factors, 1 and 2, right? If we look at 5, it has two factors, 1 and 5. So the prime numbers are the numbers which has two factors. One of the factor is always 1, and the second factor is the number itself, right? Similarly, if we look at number 9, it has three factors, 1, 3, and 9, right? So the 9 is not a prime number, right? Here you can see 3, 1. In the same way, 2, 5, 7, 11, 13, and 17 are prime numbers. Then we will see what are composite numbers. Composite numbers are actually the opposite of prime numbers, right? A composite number has more than two factors, which means apart from getting divided by the number 1 and itself, it can also be divided by at least one integer or number. So for example, if we look at number 6, it has three factors, or four factors, 1, 2, 3, and 6 itself. If we look at number 9, it has three factors, right? So you can see apart from 1 and the number itself, there are one or more factors of these numbers, right? So these are composite numbers, like 12 is the composite number, 6, 4, similarly 20, 30, 35, all that are composite numbers. So from where we represent composite number as C, and it starts from 4, 4, 6, 8, 9, 10, 12, 14, and up to so on. These are composite numbers, right? Then we will see compute power of real numbers of the form x to the power of a, where a is any rational number. So we should know about the exponents, the power of a number. If we look at a simple number, for example, 2 to the power of 2, you should know what do you mean by 2 to the power of 2. It means 2 times 2, right? And we know 2 times 2 is just 4. Similarly, if we have 3 to the power of 3, it means 3 times 3 times 3. And we know 3 times 3 is 9, 9 times 3 is 27, right? Similarly, if it's 4 to the power of 4, it will be 4 times 4 times 4 times 4. So we should know 4 times 4 is 16, 16 times 4 is 64, and we will see 64 times 4 is 256, right? So this is the concept of the exponent, the powers. 2, 3, 4. Similarly, it may be any number like 2 to the power of 5. Then you have to multiply 2 5 times. And if it's like 3 to the power of 4, you have to multiply 3 4 times. There's the concept of the exponent. And what does the square mean? Square mean always when the exponent is 2. Like you can see 8 to the power of 2. It may also called as 8 squared. And it's 8 times 8. We know 8 times 8 is 64, right? And then what do you mean by cubes? Before going to square root, we will discuss what is cubes. If we have like 4 to the power of 3, right? If the exponent is 3, it is called cube. It means 4 times 4 times 4. It's 64, right? So the cube of 4 is 64, right? Then we have to see what is square root. Square root is usually represented by this symbol, and if we have square root of 4, you know it's equal to 2. And if we have square root of 9, it's 3, right? So what do you mean by square root? When we have square root of any number, it's actually 16 to the power of half, right? So you know 16 can be written as 4 squared, because 4 times 4 is 16, and these two cancel out, and it will become just 4. So square root of 16 is just 4, right? And what's square root of 25? It means 25 to the power of half, and you know 25 can be written as 5 squared and power of half. These two cancel out, and you will get just 5. So square root of 25 is 5, right? Then what do you mean by cube roots, right? I will explain it here. Cube root. Cube roots of any number is represented by like this. What do you mean by cube root of 27? It means 27 to the power of 1 over 3, right? So if you look at 27, if you decompose prime factors of 27, you may know. So 27 can be written as like 3 times 3 times 3. So it's actually 3 to the power of 3, right? And then we will write it. So this 3 and this 3 cancel out, and you will get just 3. So what's the cube root of 27? It's just 3, right? Similarly, you can find what's the cube root of 125. So first we will find the prime factors of 125, like this. You have to divide 125 by 5, then 25 by 5, then 5 by 5, right? So it's 5 times 5 times 5. It means 125 can be written as 5 times 5 times 5, which means 5 to the power of 3. And here this cube root shows it's 1 over 3. This 3 and this 3 cancel out, and you will get just 5, right? So the cube root of 125 is 5. So whenever you have to find the cube root,